architecture, right? Okay. Yes. Yes. So what is exactly computer organization? So what do you mean by organization? What is a computer exactly? Right. So we know that a computer is not a simple box. It consists of number of things, right? So it consists of some, say, what we see with our eyes, that is the keyboard, the mouse, that is screen, right? The CPU, all this. So all are combined together. Then we call it as a system, right? You call it a system. A system is nothing but a complete computer is called to be a system. There is a lot of difference. I mean, there is a minute difference between the terminology called computer and a system. Okay, right. Okay, so a simple difference is that you call a computer when it does not have a user, and when the user is also combined, you call it a system. Anyway, there are some terminologies which you must know in our computer language. So that is why I told you the difference between a system and a computer. Right. So a computer organization is concerned with the way you cannot tell that it is a computer because those are things only which you can see. But there are number of things which are not visible to our eyes, but of course visible when we dismantle the system, right? So you are combining all these things together to form a machine called as a computer. And combining all this is called to be an organization. Organization of all these hardware components. So I suppose you know exactly what is hardware and software. Okay, the components which can be seen, which can be touched are called to be as hardware components, right? So combination of all these hardware components together as and how we are going to operate them, right? How we are going to operate them and how they are connected is called to be as computer organization. Like in the last time I was telling, I don't know whether you have got it into your mind. Anyway, I'll repeat the same example. Last time I was talking about a human being, a man or a woman, whoever it may be, a human being. Now you call a human being as a complete man only, or a complete human being only when he has two hands, two legs, a head, and other parts of the body, right? So when all these are combined together, then only he is called to be a complete human being, right? And there is something called as the brain, right? The brain thinks what to do. And if you have to move any part of your body, you get the order from your brain and you act according to that order of your brain. Am I right? So in the same way here, you are having number of components together combined called as the hardware components, which are combined together called as the computer organization, and those connections together form something called as how to do a particular task, how to do a particular work on the system, right? So that thing is called to be, your combination of all this is called to be a computer organization, right? Yes. Then what is a digital computer? So what is the difference between a computer and a digital computer? Is it different or both are the same? No. Okay. So a digital computer is nothing but it is a system that performs various computational tasks. Yes, it performs various computational tasks. Now, what are these computational tasks? Whatever you give, the user gives some task to the system, and that tasks are being performed by the system. So, it is a computational. What is computational? It may be arithmetic, it may be logical operations, it may be arithmetic operations, right? Yes, and here what the system can understand, because I hope in your first year you have already gone through C language. I suppose you all have knowledge on Python also, and you have knowledge on different computer languages. Now, do you think the system can understand these languages? Certainly not, right? The system can understand only one language, that is called the machine language, or in other words, binary language, right? The binary language is nothing but it contains only two values, that is zeros and ones. Zeros and ones, right? And each, of course, as I told you, binary digits means zeros and ones. Individually, this binary digits are called to be a bit. Okay, one single bit. Okay, right. 8 bits equals to 1 byte. Right. Okay, and the information is represented in digital computers in group of bits. Right? You simply don't give 1 or 0. A combination of ones, a combination of zeros, a combination of ones and zeros. Okay, they are combined together to make the system understand in the machine language. You say hash input str.h. Certainly the system will not understand what is hash input str.h. You say printf something something. No, the system does not understand what happens exactly. Okay, that we will see. But it is clear that whatever you give, that is being translated to zeros and ones, and it is made understand to the system. Right? Okay. Next, in digital computer, what is computer design? So computer design, as I told you just before, you are having different hardware components, you are combining them and making the system to understand what to do or how to perform a particular task. Right? So how you are designing it? How you are designing it? That is very important. As I told you before, a simple example, a complete human being has 2 hands, 2 legs, head, body, this, that, all different parts. Right? Now how hard it will be when you have hands below and legs on your shoulders? It is reverse. You imagine the same. That means you cannot perform anything properly. When you have a disorder, you cannot perform anything properly. That means the design must be designed in a particular format only. So computer design is concerned with the hardware design of the computer. Right? So there is a particular format, or there is a particular thing of how they must be organized. Again, a simple example I will give you. KMIT is an organization. So KMIT consists of number of branches like engineering, degree, intermediate, and so on. Keshav Memorial. Right? In the same way, KMIT alone consists of number of departments. It may be teaching faculty, non-teaching faculty, it may be management, it may be data science team, it may be ML team, like that. You are having number of things. Right? Of course, take a CSE department. Now, there is a particular structure like the management, then the HOD, then the coordinators, then the class teachers, then the class faculty, then the class representative, and then the students. Right? It is being organized properly. So, when you are designing it, you call it something called as an architecture. An architecture must be designed in such a way that it must be very comfortable for the user to do anything. Of course, nowadays, while computer science is the top in the world, means human beings are comfort with it. The type of organization, the type of architecture is being used is comfortable. That is why they are going for it. Right? So once the computer specifications are formulated, it is the task to designer to design it. I'm sorry, the design is not there. Okay, please, sorry for that. Okay, right. So your user specifications. So you are going to buy a new laptop, or you are going to buy a new system. You go to the shop. You tell me your specifications. I want i3 processor, i4 processor, i5 processor, whatever it may be. Your RAM must be this much. The cost must be this much. My budget is this much. Right? All the specifications. In the same way, in an architecture, the specifications are formulated. What do you mean formulated? You are not only telling, see, you say that I need a i3 processor, and you say that I want only 250 GB is enough, 250 GB is enough for my particular laptop. But what work you are going to do in the system, the memory, it cannot access that much. Right? You do, or you specify your things according to your requirement. Right? Okay. So computer design is concerned with the determination of what hardware should be used and how the parts should be connected develop hardware for the system. So that is what I explained till now, right? So computer design is concerned with the determining what hardware will be used and how the parts should be connected, right? Yeah. So this is what a computer design, computer architecture, right? Yes, I was talking about architecture. So when we talk about computer architecture, it is the structure and behavior of the computer as seen by the user, right? It is the structure and behavior of the computer as seen by the user. It includes information, formats, instruction set, techniques for addressing memory. Now what are these information, formats, instruction set, techniques for addressing memory? So so these are very important terminologies which you must know in our subject. Anyway, we'll be going deep into that. But before going to that, just let us assume of what happens exactly when we give a particular task to the system. You are going to write a program, you say hash include sto.h, you say main, you say int a comma b comma c, you say a equals to 10, b is equal to 20, and you say c equals to a plus b, you say print c, percentage b, c, whatever, right? Now what happens exactly here? So when the user gives some data, some information to the system, it is called to be input. And what you are expecting or what you get from the system, the information, the data which you get from the system is called to be the output. Now this particular information which you are giving to the system, you type a program. Now what happens to the program, or to which part does that particular program go? Does it go to the screen? Does it go to the CPU? Or does it go to anywhere? How does it work? So before that, we must know what are different type of architectures we have. So basically there are two types of architectures, two basic type of architectures or computer architecture which we have. That is first one, von Neumann architecture, which was designed by John von Neumann. Okay, it is the idea of a stored program concept. And next the Harvard architecture. Yes. Now what are these architectures? John von Neumann is the person who introduced the concept of stored programming, right? So it was a general framework of structure that a computer's hardware programming data is. Data is stored, again, sorry, there it's missing over there. Okay. Okay, that means in this architecture, basically Mr. John von Neumann, what he has done is he has proposed an idea, or he has developed an idea of storing a particular data and analyzing it and completing the task by the system. In that, he has visioned a particular architecture which contains mainly three things, that is keyboard, monitor and CPU. So in this CPU, he has designed a particular architecture such that he is having three things, that is the ALU, memory and control unit. So ALU and ALU, arithmetic logic unit. Memory, in memory you are having number of types of memories, primary memory, secondary memory. But initially you are having memory called as RAM, that is random access memory. It is the computer's primary memory which is fast. Right? And next you are having the control unit. So this is a component there. This is a particular component where it instructs what to do and how to do. Okay? What to do and how to do. Right. Now, yes. Yeah, I was telling you a small, a small issue just before. You are writing a program, and to where does this particular program go? Obviously, it goes to the memory first. You can just take a simple example, the human brain or a human being. So when somebody talks to you, whatever he talks, that goes into your memory first. Right? It goes to your memory. And then you again start giving him reply. right? That's what the same thing happens here. So if on the screen you can see the fourth one, man-machine interfaces. As I told you just before, you are giving some information that is called to be input, and you are getting some data that is called to be output. And the devices used for input is called to be input devices. That is the keyboard, for example. One of the example, you are having number of input devices, but mainly keyboard. And the devices which are used for getting the output is called the output devices. Example, the monitor. So it is given there, such as keyboard for input and display monitor for output. Right? So an example of computer architecture based on von Neumann concept is the personal computer. So whatever we are using today, those are all depending upon the von Neumann architecture. Right. Next, the next type of architecture, Harvard architecture. So the Harvard architecture physically has two separate pathways, one for the storage and other for the signal. Right. So in the first point you can see the Harvard architecture uses physically separate storage and signal pathways for their instruction and data. Okay. In a computer with Harvard architecture, the CPU can read both an instruction and data from memory at the same time, leading to double the memory bandwidth. That means whatever instructions you are giving, those are stored and read at the same time. Okay, and you are having, and this mainly you are having this particular architecture called as Harvard architecture depends upon the microcontroller. Yes, microcontroller. So an example for this Harvard architecture is the digital signal processors based computer systems. Okay, so previously von Neumann concept, you are having the CPU consisting of ALU, memory and control unit, right? So there you are having the microprocessors, here you are having microcontrollers. In other words, you can say the CPU can also call be as, the ALU all are comprised of microprocessors, right? Yeah. Yes. So this is the block diagram of the von Neumann concept. So in the von Neumann concept, as I told you, you are having input devices and you are having output devices, right? So input devices are used to give input. So using the input devices, so you can see my cursor over there. So you are giving input using the input devices and you are passing it to the processors. So in this processors, you are having the CPU, and in the CPU you are having the memory. Of course, you are having ALU also, which resides in the CPU, right? So whatever data you are giving using the input devices, that is being sent to the CPU, and in CPU the memory axis takes control of the particular data, and then it goes to the control unit. The control unit takes the complete control of the particular task or instructions, and it decides what to do, whether it will go for arithmetic operations or logical operations. That means an arithmetic logic unit, that is ALU, performs all arithmetic operations as well as logical operations. That's why we call it as a ALU, arithmetic logic unit. From the CPU, the data has been processed and sent back the particular answer, or you call it as output, right? So it processes the input and again it processes the output and gives the output through the output devices. So as told before, the input device is keyboard. Using the keyboard, you are using the CPU, and from the CPU the data is being processed, and after processing all the data, you are getting output using the output device, that is the monitor, right? So this is a simple this is the concept of von Neumann architecture, which was being developed by John von Neumann, right? Okay, so let us see what else is there in our basic computer organizations, right? So basic computer organization contains three main components: CPU, memory and input output subsystem. That is the processor what we have seen. Yeah. So here I want to specify one more thing. We call something called as CPU. What is CPU? Central Processing Unit. And we have nowadays we are using some other thing called as GPU, Graphical Processing Unit. That's also used, which is used for a particular graphics on a system. Okay, which is there with the CPU only. Okay, anyway, yeah. So generic, yeah. Again, see. So how the particular instructions in the memory are organized? How are they being used? How are they being controlled? They are being controlled by bus. So what are bus? Bus are nothing but, in simple language, wires. Okay, why? In our terminology we call it as bus. See, every subject has some terminologies. Terminology is very important. When you are writing your exams, when you talk something about the subject, the terminology plays a vital role. So see that you follow the terminology. Terminology is very important. In general, when we talk about something, say for example, you are talking about movies. What is a movie and what is a cinema? The terminology is different, right? Both are the same, of course. Cinema, movie. Both are, the terminology is different, but the concept is same. Right? I'm just giving an example, okay? So don't take it into mind, just to make you understand, to make it simple, I'm just giving you some examples. Right? Okay, fine. So in the same way here, a wire is going to be a bus. And see, the CPU, the input output devices, and the memory subsystem, all are being used by the bus. Basically three types of buses: address bus, data bus, and control bus. Now what is address bus? What is data bus? What is control bus? Of course, data bus means which carries the data. Control bus means the wire which takes control totally. And address bus is the wire which takes the control of the address. So what is address exactly? So you are saying, as I told you just before, you are giving a program, you are saying int a, b, c. Now where is a, where is b, where is c? With no doubt the simple answer will be it's in the memory. But in the memory, where it is? It has some location. It has some particular address. Simple, we all live in the world. When somebody asks you where do you live, you don't say that I am living in the world. Or you don't say that I am living in India. You don't say that I am living in Hyderabad. Until unless you are out of it. If you are out of Hyderabad, then you say I am from Hyderabad. But if you are in Hyderabad, you say I am from Dilshik Nagar, I am from Secunderabad, I am from Uppal, or I am from so and so area. That is the address. Right? In the same way here, whatever data you are giving, that data is being stored somewhere having a particular address, and that the address is to be, of course we are not going for that address now, let us forget about that. That address is to be known in some cases, if it's in some cases, not every time anyway. So whatever, as I told you, whatever data you are giving, that is being stored in a particular memory which has a particular location called as address. And now when you are going to manipulate your data, the data or the location where the particular data is being stored, that is to be fetched back. That is to be fetched, retrieved. You say retrieved. Now in COA I say fetched, fetching the data. Okay. I hope you all have you know what is scanf, right? So in scanf you say printf, enter the value of A and B, scanf %d, ampersand A, ampersand B. Now what is this ampersand A, ampersand B? It is the address of A, it is the address of B. That means that particular location is stored for the variable called A. That particular location is stored for the value of B. Right? So that is address bus. Okay. The data bus, of course, it transfers data because you are giving input. That input has to go somewhere. It has to go to CPU. It has to be processed. It has to go to the ALU. The data has to be process. So to process that, you need a data bus. This control bus. Of course, there will be something which takes control of all this. You have your hand, you have your legs, you have different parts in your body. It doesn't mean that you can use it whenever you want and wherever you want and however you want. No. The mind has to tell you that keep your hands in control, keep your legs in control, keep your tongue in control, keep your mouth in control. Right? In the same way, a control is to be taken. Right? Yeah. So you can see here, right, all these constitute together and they are processing the data. See, input output subsystem, they are processing the data. They are accessing the memory. Right? This will give you input and output. So input is taken. So you can see input is taken. Right? And again input is given back. Sorry, output is given back. Right? Yeah. Yes. So what does this do? That's what I was talking about till now. So mainly there are three buses: address bus, data bus, and control bus. So address bus. What is address bus? Is the uppermost bus in the address. The uppermost bus is the address bus. When the CPU reads data or instructions from our memory, it must specify the address of the memory location it wishes to access. So as I told you, scan of &A. So when you are using A, it goes to &A, takes the value and uses it. When you are saying B, it goes to the location where B is there, it takes the value and it does the performance. Yes, you are saying C, it goes to the location, there is no data in C. So what you are given is that C equals to A plus B. That means take the value of A, take the value of B, go for an arithmetic operation A plus B and store it in C. Now you are going for ampersand C, that whatever value of C you are getting, that is stored in ampersand C. You are not knowing where it is stored, that's why you are not using ampersand C anywhere. Alright? Yeah. Yes, the data bus. So data is transferred via the data bus. When CPU fetches data from memory, it first outputs the memory address onto the address bus. So it fetches the memory and it uses the particular data. Then memory outputs the data onto the data bus. As I told you, we said ampersand A. Then if you give ampersand A only, you get the value of A. If you are saying ampersand B, then only you get the value of B. Right? Then the memory then reads and stores the data at the proper locations. Right? Next, control bus. Control bus carries the control signal. The control signal is the collection of individual control signals. These signals indicate whether data is to be read into or written out of the CPU, as I told you. So where you are giving your input, what output is to be given, everything the control bus will take care of. Right? This instruction cycle. Yes, what is instruction cycle? The instruction cycle is the procedure a microprocessor goes through to process an instruction. You are saying C equals to A plus B. You are taking A, you are taking B, you are adding them and storing in the location of C. Right? It is an instruction cycle. So what you are doing here, you are mainly doing three things. You are taking the value of A and B. You are decoding it. That means in A you are having some value 10. In B you are having some value 5. Now the system cannot understand what is 10, what is 5. It has to convert it. It has to convert 10 into binary, 5 into binary. Add those two in binary. Get your result in binary, but give the output in number. That is 10 plus 5. That is 15. So what you did first? You took the value of A and B, fetching your data. First one. Next you are converting that into binary values, decoding them. Second one, decode. Right, and you are executing it. The third one, fetch, decode and execute. Yes, fetch, decode and execute. The processor fetches or reads the instruction from the memory. It decodes the instruction, determining which instruction has fetched. Finally, it performs the operations necessary to execute the instruction. It performs some operation internally and supplies the address, data, and control signals needed by the memory and input output device to execute the instruction, right? Next, control signals. Okay, so let's forget about control signals. I hope you are able to understand. So these and all you'll be getting it in the coming classes. Okay, so for now, just I hope you have understood what I have discussed till now, right? So till now we have discussed about what is computer organization, what is a computer design, what is computer architecture. In computer architecture, what are the two types of architectures, right? And after that, in that particular thing, we are going to see, we have already seen what is the two types of architecture. There is one Neumann architecture and Harvard architecture. So what is there in one Neumann architecture? The CPU. In CPU you are having mainly memory, and you are having the ALU, and you are having the CU control unit. Now all is connected with something called as bus. What are the type of bus we have? Address bus, data bus, and memory bus. So what are they going to do? The address bus takes the address, the data bus transfers the data, right? And the other one, control bus, takes the control of all these. So when you are going for a particular operation, mainly you are going to go for three things. What are those? Fetch, decode, execute. Fetching the data, decoding the particular data, and executing your particular data is being executed. So here you are going to give your data using the input devices. An example is the keyboard, and the particular data, the particular information is being processed inside the CPU. So here one more thing, please note that in our different types of architectures, that is Harvard architecture and one Neumann architecture. So in one Neumann architecture you are going for microprocessors, in Harvard you are going for microcontrollers, right? Yeah, so whatever data is being processed in the CPU, that is being given back or it will be executed and sent back to the system, or sorry, it is sent back to the user in the form of output using the output devices, that is the monitor. So monitor gives you the output, right? So basically whatever data you are doing, whatever operation you are doing, you are fetching the data, you are decoding the data, and you are executing your data, right? So yeah, so we have covered the introduction. What is computer organization? What is a digital computer? Block diagram of a digital computer. What is computer organization? What is computer design? What is computer architecture? And some other concepts we have seen, which are internally residing in these concepts. Right? So we have completed the first section of the unit 1. Okay, first section of the unit 1. So we have seen the introduction, block diagram of computer organization, and architecture, computer design, and so on. Yes. So that is about today's class. So if you have any doubts, the time is 4:57. I give you 3 minutes time. If you have any doubts, you can post in the chat box, and at 5 we can start the quiz. If you have any doubts, please don't raise using this particular thing here, which I am getting some requests over here. Okay, please raise your doubts in the chat box. The chat box is available for everybody. You can type in chat box and you can ask me if you have any doubts. Still no? Yes. Any doubts? Please go on. Any doubts? Hope my lecture was audible, understandable and clear. So if you have any doubts regarding my session also, you can post on the post the feedback also in the chat box. If you think my class was not understandable, if you have any comment on my class, if I am a bit fast or slow or whatever it may be, you are welcome. You can comment on in the chat box. Well, it's 4:59. Yeah, one more minute. I'll give one more minute. If you have any doubts, you can post.